The following presentation is for NEXIO's BAT-EMC software. In this example, we will be exploring the conducted immunity test according to CISPR. This is a supplement to the previous presentation on the general test case. In this example, we're going to explore the requirement for linearity checking. As you can see in the extract from the standard, there is a requirement to increase the level of the RF generator by 5.1 dB. Then we will monitor the difference between 3.1 and 7.1, and if it is in tolerance, there will be no fault. If it is out of tolerance, then we will log a fault. To show how we accomplish this, this is a previous test that was run, so we're going to duplicate that. We need a test that is free of data. I'm going to change the name to linearity check so that we can identify what this test is for. If I click on the Tools button, I can see that I have a linearity tool already active. If I click on the properties, you can see that it is an increase of 5.1 with a margin of plus and minus 2. This is the range. And we'll select OK. Go to the Parameters tab and then press Execute. As typical, the block diagram appears with the same resources. You can see that the linearity tool is indeed activated. In simulation mode it is rather fast, but indeed the generator is being changed and we are monitoring it in the correct zone. If I go to the Monitoring tab, you can see we're at 5.1. If there was to be a fault, then it would be shown here in the log. I can stop and we can show another example. Now I will right click on this test, duplicate it, and change the name to threshold. So that we know we're going to explore some threshold examples. For that, we make sure that the tool is activated for threshold seek. I will ask for an increasing level. We will start at 20 dB below and go in 1 dB steps. This is for the automatic threshold search. I will demonstrate both the automatic and the manual. We now execute the test. We will allow it to increment forward by a few frequencies, 150, 151, so on. Now I can just simply stop and select a sub-range, select manual mode, and we can select apply. The block diagram appears. Now RF is being generated, as you can see by the symbol here. Next, I will increase the signal generator level from this starting point in increments of 1 dB. You can see here I'm at minus 20, now minus 19, minus 18, and so on. When the fault occurs, I could click on the fault button or hit the space bar and make a comment. Also the fault button here. For example, I could state fault 101 and then I can return to automatic mode. It will continue to increment forward from where we left off. I can now enter that same menu from another method. Now with the manual mode activated, I can select threshold search. It will do a threshold search automatically for that frequency, incrementing from the lower level all the way back up to the target. As you can see, it is incrementing at that frequency. When it is automatic, we have this message shown here. Now the test continues to the next frequencies. If there was a fault detected, it would have been shown automatically. I will stop the test. End the test. And this concludes the demonstration for linearity checking, as well as the threshold search manual, as well as automatic mode. This concludes the NEXIO presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.